yeah, I really work on visual attention since my PhD thesis, and that's why I will not talk about this now. I will talk about creativity. But however, I will tell a little bit about attention because it could be an interesting step in there. So what I will do is I will show some examples. So some were already shown today in different speeches. Everything is not there, of course, but it's just to have a view of examples of AI creativity. And then we'll try to see how an AI algorithm, at least deep learning based, can be creative. Can it be creative, actually?
Well, and this is the first part.
Oh, sorry. Stop. Yeah, so here you have maybe one of the first real artificial intelligence systems, which was based on Ant's algorithm. So the idea is that you have a system which is composed of several subsystems which interact together and have cooperation. And by doing this cooperation, they do these great drawings that you can see there. And then more recently, you have this robot which drawn surface of Mars with only one line, okay, without using several lines. So it's 900 million movements to make just one line for a painting. So this is all about robotics. That one is really interesting, and I at the end I will let you maybe 1 minute, if I'm not too long, of a video of what it's doing. So Shimon is actually singing, composing lyrics, playing, and making choreographies with his head like that, following the sound. And it's really very interesting because it is a collaborative system, and I'll really try to emphasize this, that artists actually need to be in the loop, and humans need to be in the loop to have something which really works well. Well, text. So text we saw with Bruce, also newer systems. So these are older systems. So you know all the Shakespeare text, which was made by an AI. Also some coding, and some full AI book, which was done automatically. And as you see on the title, it is as weird as you would expect it to be. Okay, so if you have the AI alone, again, you will get something weird at some point. Sound. For sound, you have this symphony of Beethoven, which was finished by an AI algorithm. I mean, based on a data set of Beethoven, but also other kind of artists which are related to Beethoven in there. And maybe more interesting, the Alex da Kid hit, which was made by an AI. And what is interesting here, so they used the IBM Watson system. What is interesting here, again, is it worked very well because the system was proposing text and proposing sound, and the human was accepting or not the words and the sound. And in this case, it works. So again, if it's not alone, it works. If it's alone, not yet. So that's my favorite one. The AI whiskey. So this is not IBM, this is Microsoft Azure platform. They used it to make a recipe of whiskey based on data sets on that. And of course, you have quite a lot of application now where you can take a picture of what you have in the restaurant, and then they will detect that it's a burger, and you should not eat it if you really want to lose weight. and then you say, okay, I already know it, but I still eat it. Up. Then you have the body. This is also very interesting. So here there is an artist who provided his entire data set of movements, so skeleton movements of dancers. And what they did is that they try to see if they find different ways to combine those poses, and then ask to some dancers to try them, and they really like synthesize interesting dance movements. So again, a collaboration between artist and the machine, and not the machine alone. Okay, so that one I will be faster because it's about fashion and a lot of sensors that you can have on your clothes, etc. For drugs, that one is really interesting because the model was initially made for text processing, grammar processing, etc. And they were able to switch it into completely another domain, which is about it's called Nova drugs in there. So the idea is to find the good fit to be able to go and stick on an active site. So for design, of course, you can synthesize shoes, but you can also synthesize chairs. By, for example, trying to optimize the materials which are used in there, etc. And this can give interesting results. And of course, we talked about action and motion. Action is really important, and part of artificial intelligence, which is based on on gaming and reinforcement learning, and the fact of I'm doing a motion, something happens, it's good or bad, I learn from that, etc. This really works very well. So as you know, you all know AlphaZero, I suppose. So yeah, it's written in there. In 24 hours, the model was much better than any human. So what happens is that the human resigned. Okay, and
but simulation is not about.
This is some sound that I let in there. So what I was saying in there is that it was another application about actually dogfighting with F-16, and the model became better than the pilots at some point. Some other creativity is about this kind of images. So you see that one, which is quite well known now. It's how the networks dream. So do they really dream, or is this anthropomorphization? That's another question. So you put an image in there, which could be whatever image you want, and then you make iterations. And at some point you have more and more clear objects, which are the objects that the model encounters most often in the dataset, in the trained dataset. And of course, you can also make some money with that. So there is an artificial intelligence which made this great artwork. So it was sold for $100,000. You can check if you like it or not, but it's a good idea to get money, maybe. And finally, I will finish with that one, which is also very well known. In image processing, you can take a style in a picture and take another picture and apply the style of the first picture to the second picture, and then you can have Steve Jobs in Van Gogh, etc. Okay, so now we had a very fast view of what happens in creative AI. let's try to understand what is creativity actually and how it can be applied in there. Nope. No. Yeah. Beam. Okay. So one definition, of course, I don't have the perfect definition, is that something creative is something which might be novel, so it's more on the left, and at some point valuable. So valuable means usable, but it can also just mean beautiful. Okay, so one of the approaches is to say that there is a conceptual space with a search space here and a boundary, and the idea is to push this boundary and to change the search space in order to be more creative. So, like, okay, so left hand works better. So just some ways to be creative. So exploration, combination, transformation of the space, and this transformation can be done by convergence or divergence, etc. So these are some kind of ideas about how to be creative. And actually, if we look to the algorithm that we have currently nowadays, they are very good in transforming the space search. So they are based on optimization. Okay, so you have a space, and you try to optimize the loss function in there, and to optimize and to find the best solution on your space, actually. So you will always get the best solution possible given your system on your search space, but it will be very difficult to enlarge the search space, to try to get out of the search space, and to try to explore, to diverge, let's say, and not to converge. Optimization is more about convergence. Yeah, and you see in there, oh, no, it worked too well. That's in this part, the attention is actually back. Because, of course, deep learning works well, very well, if you have a lot of data, well labeled, which actually never happens. Well, in some cases it happens. So then it's great. But if you have a few data and you have like weird things, you don't have a specific class, you have defects, surprising things arriving in there, then deep learning is very bad. And then like more bottom-up attention is interesting. So when you fail to compress the statistics, as we said that deep learning is compressing statistics, if something is rare or unusual, it will be very difficult to compress, and that's where our attention is attracted, because something is weird. Okay, so you have like a homogeneous image is easy to compress, but you have a white dot in the middle. Say, what that? Okay, so both systems should go together. So there is more and more attention in transformers, for example, but it is more, let's say, a top-down attention. So the attention learns how to look to features which will help it to find a given solution. Okay, so classifying something or whatever. But it's not something like, whoa, something happens, what does it mean, what can I do, how can I adapt, etc. And another approach to creativity, so there is a kind of classification. So mini c, little c is like classical creativity, everyday life creativity. Pro C, something more creative, but with no revolution in there. And big C is like the disruptive thing. And at least in my opinion, most of the examples I showed are mini C and little c. Some can be pro C, especially the alpha 0 related ones. And maybe the one with the drugs, okay, because you begin by using a model in one domain and it changes in a second domain, so that's interesting. And for me, no one is really big C. And there are three things to take into account in there. First of all, multimodality. So we as humans, we don't have just one network in our head. We have a plurality of networks, talking about a plurality of experience that we made in our life, etc. So multimodality, meta models, which means that making models, taking into account several models. So for the moment, this is more or less manual. And something which is really important is that deep learning is based on optimization. And optimization, by definition, will find the best solution, which will be necessarily a good solution, but maybe not the best one. And I will try to talk a little bit more just for the conclusion here. So three things. For sure, deep learning is something which brought a lot to, let's say, creativity. If we go like 10 years ago, there are a lot of things that we were not even dreaming in there. So that's really an interesting step. I will go to the third step directly. The third step is what I said several times. The system which really works in at least in those that I know, are systems where the human or the artist or whatever is still in the loop, okay, and so can provide, decide if what the AI is saying is good or not now or later, etc. And maybe the thing in the middle is one which is interesting. If you really want a system to be creative, it needs to be some faith. It means at some point the system should say, I feel like this solution is good. I have no proof about that, but I feel like it's good. I will try it, and most of the time it will be bad, but sometimes it will be good. Okay, that's like that genetics works by errors. And so machines should have some faith, and yeah, even if something is suboptimal, maybe it's suboptimal now, but it can change. It can be really a big change. This is something very important. And maybe to finish up. So yeah, takeaway message is that for the moment, at least in my opinion, disruptive creativity is human-only capacity, and optimization-based creativity is a machine capacity. So if you put both together, then that's great. If you just use one of them, well, use human. Use human alone, but not AI alone. And yeah, so it's really about collaboration, and that's here where I will put 50 seconds.
Let me be music or a star into your mind. I'll clear this magic rules, 'cause I won't wait for you by my side. My whole life, shades of delight, rich as a book before night. When will I see if one is waiting for me? Who could it be? And when you leave me on my way.
So sometimes it's good when it finishes. Yeah, thank you.